The slope field that we're going to draw for example 2 here is a little bit more complicated than the one we did in example 1. In this case we have dy dx is equal to x plus y. Now you might find it helpful to pick out a couple of example coordinates, plug those coordinates into the equation for the slope, and use that to find out what the slope is. After a while you'll be able to spot certain ways to do this a little bit faster, and that has to do with patterns that you'll see in just a minute. So let's start out with the coordinates first. I'm going to take this coordinate up here, 1, 3. Just write it off to the side. You obviously don't have to do that because the slope field will get a little bit cluttered if we do too many of those. You might find it helpful to write the coordinates off to the side as you're doing your slope field. At the coordinate 1, 3, we know dy dx is x plus y, so dy dx is 4. So I want to draw a pretty steep positive slope. Then we have 1, 2 right here. That'll be a positive slope that's a little less steep. 1, 1, a little less steep even than that. And then 1, 0, which is slope 1. Notice I'm just trying to get it approximately right here. One thing that you should notice as you're doing this is that the slope is going to be 0 anytime x plus y is equal to 0. In other words, y is equal to negative x will produce a 0 slope. So all along this line y is equal to negative x, we can go right ahead and draw a 0 slope. Also, you should notice patterns as you go along that say that every time that the x coordinate goes down by 1, the y coordinate would need to go up by 1 to give you the same slope. In other words, as we're going along, these diagonals will help show us exactly what's going on with our slopes, because along the diagonals the x and the y values will both add up to the same constant value. So for example, at 0, 1 we get a slope of 1, which just so happens to be the same slope at 1, 0. Similarly, we get the same slope at negative 1, 2 and at negative 2, 3. So all along the diagonal above y equals negative x, in other words y equals negative x plus 1, we're going to get slopes of 1. The slope will be approximately 2 on the diagonal above, and so on. The finished product is in the packet if you would like to look at that. But these are just kind of the general trends that you look at when you're trying to figure out what a slope field looks like.